So Jafar, tell me, can you explain the role of Airflow in managing ETL processes in data pipeline?
Okay. Airflow is used to schedule, orchestrate, and monitor ETL processes. It helps define workflows as directed acyclic graph DAGs, which is known as DAGs of tasks, ensuring the sequential and conditional execution of jobs. For example, in my experience, I used Airflow to manage data pipeline between Caspio and Snowflake, as well as between AWS and Snowflake. Airflow's scheduling feature allowed for automation and reliable execution of ETL processes, ensuring data was moved and transformed without manual intervention.
Nice, nice. Okay, so the next question is, okay, so tell me, how would you optimize an ETL pipeline using Snowflake?
Okay, to optimize an ETL pipeline in Snowflake, I would focus on leveraging Snowflake built-in capabilities, such as automatic clustering and micropartitioning for faster query execution. Additionally, I would utilize Snowflake's data warehouse features, such as scaling compute resources dynamically to handle large data volume efficiently. During a project, I utilized Snowflake time travel feature for data versioning and rollback, which proved useful in managing historical data without performance degradation.
Okay, so how you have used AWS Glue and Athena in a data pipeline?
Okay. In Ready Data Pipeline project, I used AWS Glue for extraction, transformation, and loading data. Glue's ETL jobs enabled data transformation at scale. And we use Athena for serverless querying of data stored in S3. This combination allowed us to build a scalable, cost-effective data processing system that could handle unstructured data efficiently while reducing manual effort.
Okay, so what are the advantages of using Apache Kafka in real-time data processing?
Apache Kafka is ideal for real-time data streaming because of its high throughput, fault tolerance, and scalability. In a smart city AWS project, I used Apache Kafka to ingest real-time car data, which was processing using AWS Athena and stored in Redshift. Kafka enabled us to manage high volume of continuous data streams reliably, ensuring low latency data ingestion and real-time analytics.
So can you describe how you implemented automation with Pandas and Snowpark?
Okay, I implemented automation using Pandas and Snowpark for data transformation tasks. By utilizing Pandas for data manipulation and analyzing Snowpark for executing transformation directly in Snowflake, we automated several processes including data cleaning and report generation. This allowed the team to save time on repetitive tasks and ensure consistency in data transformation workflows.
So tell me, how do you manage data security and access control in AWS services like Redshift and S3?
Okay, to manage data security and access control in AWS, I rely on AWS Identity and Access Management, which is IAM, to define fine-grained access policies. For example, in Redshift, I use role-based access control, which is RBAC, to ensure only authorized users can query or modify the data. For S3, I utilize bucket policies and access control list ACLS to restrict the access. Additionally, encryption at rest and in transit is enforced using AWS Key Management Services KMS for sensitive data. These measures ensure compliance with security best practices while protecting the data assets.
Okay, so can you explain your experience working with Azure Data Factory and ETL processes?
Alright. Azure Data Factory is a powerful tool for building and managing ETL workflow in cloud. In one of my projects, I used ADF to orchestrate the entire ETL pipeline, from data ingestion from various sources to transformation and loading into Azure Synapse Analytics. I leverage ADF's integration with other Azure services, such as Azure Data Lake Storage, for seamless data transfer. The tool's mapping data flow made complex transformation more manageable, and schedule pipeline ensure automation for repetitive tasks.